The James Webb Space Telescope has made a truly astonishing discovery. Recent observations reveal that the atmosphere of the exoplanet K2-18B contains dimethyl sulfide and/or dimethyl disulfide, molecules that, on Earth, are produced only by living organisms. According to scientists, this may be the most compelling evidence of extraterrestrial life we've encountered to date. It's even possible that the oceans of this distant water world are home to alien life forms. Could we finally be on the brink of confirming the existence of life beyond Earth? And what might the creatures inhabiting K2-18B actually look like? Stick around to the end, as we dive into the full story behind this groundbreaking discovery. Located just 124 light-years away, K2-18B has long been a subject of fascination among astronomers, and now, more than ever, it's capturing the world's attention. It's no surprise this celestial body has sparked such interest. Discovered in 2015, this exoplanet, about 2.6 times the radius of Earth, sits comfortably within the habitable zone of its star system. Even more intriguing, it's believed to be a so-called Hycean world, a type of planet covered by a vast global ocean and wrapped in a hydrogen-rich atmosphere. Known as K2-18B, this world is roughly 8.6 times more massive than Earth and orbits a red dwarf star in the constellation Leo. It grabbed headlines in 2023 when the James Webb Space Telescope detected traces of dimethyl sulfide, DMS, a sulfur compound considered a promising biosignature. That discovery was no coincidence. On Earth, DMS is produced solely by living organisms, specifically by marine plankton and during the breakdown of organic matter. It's also the compound responsible for the familiar scent of the ocean breeze you catch when visiting the coast. The initial discovery of dimethyl sulfide, DMS, on K2-18B was undeniably thrilling, but there was a significant caveat. The signal wasn't particularly strong and only became apparent through a very specific method of data analysis. At the time, the DMS signature was detected using the James Webb Space Telescope's near-infrared spectrometer, NIR-SPEC, showing up at a wavelength of 3.4 micrometers. However, that presented a major challenge. The signal overlapped heavily with methane, making it difficult to clearly distinguish between the two. Scientists suggested through modeling that, under certain conditions, biogenic sulfur gases like DMS could accumulate to detectable levels on hydrogen-rich planets. But confirmation required a fresh, more targeted observation by the Webb telescope. Now, that follow-up has been carried out, and the results are nothing short of extraordinary. What Webb has just uncovered on K2-18B may well be remembered as one of the most groundbreaking discoveries in the history of astronomy. Have we finally discovered signs of alien life? Nikku Madhusudhan from the University of Cambridge hinted at the excitement early on. The initial clue was thrilling enough to warrant a fresh look at the exoplanet using the James Webb Space Telescope, but this time, with a different method. That's exactly what happened. The lead author and his team turned to Webb's MIRI spectrometer to dig deeper into the search for biosignatures. Unlike the NIR-SPEC instrument, MIRI works in the mid-infrared range, between 6 and 12 micrometers. And that makes all the difference. Gases like dimethyl sulfide, along with other potential biosignatures, are expected to leave even stronger signals in this part of the spectrum compared to the near-infrared. Webb had already detected methane and carbon dioxide in K2-18B's atmosphere. But now, the team may have uncovered something truly groundbreaking. The new spectral data revealed distinct peaks between 6.8 to 8 micrometers and 9 to 11 micrometers. When compared with the expected spectral signatures of 20 known molecules, researchers concluded that these patterns could only be attributed to dimethyl sulfide, DMS, and/or dimethyl disulfide, DMDS. Matt Houston's team explained, "Our findings confirm the clear presence of just two molecules, DMS and DMDS." What makes this even more remarkable is the strength of the evidence. Previously, a potential DMS signature detected in the near-infrared was too weak to be considered statistically reliable. This time, however, the likelihood that the spectral features truly belong to DMS or DMDS stands at 3.2 standard deviations, around the 3 sigma level. In simpler terms, there's only a 0.3% chance that these spectral peaks are due to random noise or error. To put it more clearly, we now have evidence from an exoplanet showing, with 99.7% confidence, the presence of gases that on Earth are exclusively produced by living organisms. Hycean categorized this groundbreaking discovery with the following statement. The signal was strong and unmistakable. We've now obtained independent confirmation using a different type of instrument and detecting a different range of light. These results give us fresh, independent support for a potential biosignature on K2-18B. In other words, the new measurements offer compelling evidence that life beyond Earth could exist on this nearby ocean world. Even more intriguing, the strength of the spectral signal points to a high concentration of molecules that could have a biological origin in the planet's atmosphere. To put it in perspective, the concentration exceeds 10 parts per million, around 1,000 times higher than what's found in Earth's atmosphere. That level of abundance could suggest that K2-18b is brimming with life. Hycean elaborated, these quantities point to intense biological activity on the planet. This matches theoretical predictions for planets in high hydrogen environments, and now we've actually observed it. Based on what we currently understand, K2-18b's vast ocean may be teeming with life. But what does this truly imply? Could it be that humanity's age-old question, are we alone in the universe? Has just received its most convincing answer yet, a powerful and thrilling no? Are astronomers already celebrating what could be the most monumental discovery ever? Not quite yet. Despite promising signs hinting at potential biosignatures, experts are urging caution. More investigation is necessary to definitively confirm the existence of these elusive cosmic neighbors. The lead scientist stresses that relying on a single measurement is risky, stating, "It's crucial to remain highly skeptical of our own findings. Only through repeated verification can we be certain, that's the essence of science." Additionally, for a discovery to be officially recognized, it must reach a statistical significance of 5 sigma. This means the likelihood that the results are due to chance is less than 0.00006%. The exciting part is that this milestone might be within reach soon. Achieving the required significance could be possible by monitoring a few more transits of K2-18b as it passes its star, requiring just 8 to 24 hours of additional observation with the James Webb Telescope. While our curious infrared observations of space provide valuable insights, additional theoretical and experimental studies are essential to definitively answer the question of life on K2-18b. As noted earlier, on our own blue planet, DMS and DMDS are produced exclusively by living organisms. There is no known abiotic process that generates these molecules. However, to be thorough, scientists are exploring the possibility of non-biological pathways for these gases. Although astronomers have already begun such investigations, no evidence has yet emerged of any chemical reaction that could create these molecules without biological involvement. This doesn't rule out the possibility entirely. It remains theoretically possible that such a reaction might be discovered in the future. So why the skepticism among some experts? Because if no abiotic source is found and the biosignature on K2-18b is confirmed, it would represent a monumental breakthrough and a historic milestone in astronomy. We might be on the brink of a groundbreaking moment. For thousands of years, humans have looked up at the starry night sky, wondering if Earth is truly the only place in the universe where life has emerged. Our ancestors connected the mysterious sparkling lights above to their gods, weaving myths around the stars. Now, it seems we may finally be uncovering the secret of life beyond our planet. Hycean and his team understand the historic significance of their potential discovery. He suggests that decades from now, this moment could be seen as a pivotal turning point, the moment when the age-old question of whether we are alone in the universe might finally be answered.